Okay. In this lecture, we will see some more pointer arithmetic operators, and we will introduce those by talking about them through a problem. Okay. So, the problem that I have is that of reversing an array. So, we have to write a function to reverse an array, and let us say that the declaration of the function is void reverse array int a int n. Okay. Now, if you have to reverse an array, what is one way to do it? You take the array, copy it into another array, and then copy it back in the reverse fashion. So, you have an array A, copy all the values into B, and now you copy those values back to A in the following way, that the B's last value will go to A of 0, B's second last value will go to A of 1, and so on. Okay. Now, let us try to do it slightly more cleverly. We want to take an integer array and reverse the array in place. Okay. That means that essentially using no extra space. So, do not use an extra array in order to reverse it within A itself. Okay. So, the array before calling reverse array will look like A0 up to A n minus 1 in this way, and after calling reverse array it should look like A n minus 1, A n minus 2, etc. up to A0, and in doing that we should not use an extra array. So, how do we do this? Let us look at a bunch of couple of concrete examples to see how do we do it by hand, okay, and then we will try to code that algorithm. So, in this there are two cases. So, for example, what happens when you have an even length array, when you have, let us say, 6 elements, then A0 and A5 have to be exchanged. A5 goes to A0, A5 goes to the 0th location, A0 goes to the 6th location or the 5th location, and then A1 and A4 have to be exchanged, A2 and A3 have to be exchanged. After this you should stop, right? That will correctly reverse the array. Now, what happens if in the case of an odd length array? Suppose you have an array B which has only 5 elements. In that case, to reverse the array, you have to exchange B0 and B4, B1 and B3, and you can stop there because there is no need to exchange B2 with itself, right. So, the case of an odd length array, you will end up with an element which does not need to be touched. In the case of an even length array, you have to exchange until you reach the middle of the array. Let us try to code this up. Okay, so how is the reverse array written? First, I need, so remember how we did this by hand. We exchanged the 0th location with the last location, then we exchanged the first location with the second last location, and so on. So, it is easy to code if you have two pointers. Initially, one pointer starts at the beginning of the array, the second pointer is to the last of the array, exchange those values, then the first pointer goes to the next location and the second pointer goes to the previous location. Okay. That is how we did it by hand. So, let us try to code that up. I will have a pointer B which points to the last element of the array, A plus n minus 1. Okay. Now, the loop is as follows. I will discuss this in a minute. While B is greater than A, so remember in the example by hand, we had to exchange till we reach the middle of the array. Now, how do we find the middle of the array? I will just write it as B greater than A, and I will explain it in a minute. So, while this is true that you have not yet reached the middle of the array, you exchange swap A and B. Here we use the swap function which we have seen in the previous lecture. Okay. So, for example, it will swap the 0th element with the n minus first element. After that is done, you increment A and you decrement B. Okay. So, the design logic is that A initially points to the first element of the array, the left end of the array, and B points to the right end of the array. in general, while the algorithm happens, then A is moving forward and B is moving backward. Inside the loop, you exchange star A with star B. Okay, that's what is accomplished by calling swap of A and B, because swap A and B will dereference those locations and exchange the values there. So do this repeatedly until A and B cross over, because when A is moving forward and B is moving backward, then the middle of the array is the point where A and B cross over, or the point where A and B meet. Okay. So this is the very simple logic for reversing an array. Now I've left one thing unexplained. What do I mean by B greater than A? B and A are pointers. So what do I mean by pointer B is greater than pointer A? So we need to explain that. We are introducing an operator on two pointers. What does it mean? Okay. So we are seeing a new concept, which is relational comparison between two pointers. If A and B are pointers to variables of the same type, like in star A and in star B, we can compare them, compare these pointers using equal to and not equal to. Okay. This can be done for arbitrary locations A and B, as long as those locations are of the same type. So A equal to B is true if and only if A and B are pointing to the same location. That's natural to expect. Otherwise, if they are pointing to different locations, A not equal to B is true. Okay. Now there is another case. If A is pointing to an integer, let's say, and B is pointing to a float, then equal to and not equal to are undefined. So notice that even though this behavior looks natural, it is natural only if they are pointing to the same type. Okay. So here are operations equal to and not equal to. What about less than or equal to, greater than or equal to, and so on? And this is surprising, okay, because here is something that you don't expect. You cannot compare less than or equal to on arbitrary locations in the memory. Okay. We can compare A and B using less than. For this, they must be pointing to the same locations in the array. Earlier, when we discussed plus and minus, we were saying that plus and minus are well behaved only when you are navigating within an array. Okay. Similarly, when we are comparing two pointers using greater than or equal to, less than or equal to, then they should all be then A and B should be pointing to the same array, different locations in the same array. If that is true, then A is less than B if A is pointing to a location which is before B in the same array. Okay. Similarly, A less than or equal to B is true if A is pointing to a location which is B or before B, and so on. So for example, we can say that if we have an array int A10, then A plus 1 is less than A plus 2. Okay, that's clearly true, because A plus 1 is pointing to the location 1 in array, and A plus 2 is pointing to location 2 in the array. Okay. So if you have an array, for example, let's say A0 through A9, and PTR A is pointing to location 1 and PTR B is pointing to location 3, then PTR A is less than PTR B. Okay. Here the comparison is well defined and it's true. But on the other hand, let's say that PTR A is pointing to A of 1 and PTR B is pointing to B of 1. Okay. In this case, PTR A less than PTR B is undefined because they are pointing to two different arrays. Okay. So maybe in memory A is laid out before B and so on, but that's not what the less than or equal to operation is supposed to do. It is supposed to compare pointers only within the same array. Okay. So with this understanding, let's understand how the reverse array works. So in the first iteration, you have an array A. Let's say that the array is 101, 21 and so on. It has 6 locations, okay, and we'll run through the trace of the execution for an even length array, and I would encourage you to create an odd length array and trace through the executions to ensure that the code works for odd length arrays as well. So in this lecture, we'll do it for an even length array. So A is initially pointing to the beginning of the array, B is pointing to the end of the array. A plus n minus 1 will go to the end of the array, right? Now B is greater than A, that is true. So we will enter the loop, and in the first iteration we will swap A and B. Okay, so it will go to the swap function, and this is the swap function that actually works from the previous video. So you can assume that A0 will be swapped with A1. So they were initially 101 and 0, and after swap they will be 0 and 101. Okay. Now once that happens, A advances by 1 integer location, B goes back by 1 integer location. Okay, so this is the state after the first iteration. In the second iteration, you start with A at 21 and B at minus 101. Again B is greater than A, so you swap. Okay, so 21 minus 101 becomes minus 101 and 21. Okay, so they are swapped, and you advance A by 1 and you take back B by 1. Again B is greater than A, so you go to the third iteration. In the third iteration, this is the state at the beginning of the iteration, and you swap these contents. So you swap minus 1 and 121, this becomes the state of the array, and once that is done, B overshoots. So B goes before A and A goes after B. So I've denoted that with 2 colored arrows. So here is the B arrow, it goes to location 121, and the A arrow goes to location minus 1. When this happens, B is now less than A. Okay. So this means that you have crossed the middle of the array. Therefore you should stop now. So now B is less than A and the loop terminates. And we have seen that this correctly reverses the array. So here is how the reverse array works. We have seen the concept of relational comparison operators using pointers, how they make sense when they are pointing to locations within the same array, and how that can be used to write code using arrays.